All right, we are finding what is called the magnitude, if I can spell correctly, magnitude of a vector. And the magnitude of a vector is actually what is the length of a vector. And in layman's term, when we're looking for a length, we're looking for a distance. And if we go back to geometry, distance is found by the formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, the only difference between that formula and finding the magnitude of a vector is notation. And we're looking at notation for a vector as kind of like the absolute value, except it's usually a darker or a thicker line, or in some cases they'll do a double line. So it could be either a very bold-faced line, or it could be a double line. So it just depends on what book we're using or what program we're using. So what we're going to do is we're going to look at an example. So we're going to look at a vector, and let's say that that vector is has an initial point of -2 and -7, and has a terminal point of 6 and 1. So we're going to plug that into our formula. This is going to be x1, y1, and this is x2, y2. So we're going to plug it in. So we get the square root of 6 minus a -2 squared plus 1 minus -7 squared. So that's going to give us 6 plus 2 squared plus 1 plus 7 squared. So that's going to give us 8 squared plus 8 squared. Well, 8 squared is 64. So 64 plus 64 is the square root of 128. Now, if you're using Delta Math, which is the program that your assignment is going to be under for my particular class, it's going to require you to simplify this radical. So what you're going to do is, you know that this is 64 times 2, and that's because it was 2 64s. So we know we can take the square root of 64 times the square root of 2. The square root of 64 is 8, so we get 8 the square root of 2, and that would be your answer. All right? So let's try looking at another one. So we're going to, let's just pick some nice little numbers, and I'm a little out of focus. So let's say A is 2 and 5, and B is, let's say, -8 and -3. All right. So again, this is x1, this is y1, this is x2, this is y2, and we're going to plug it into our formula. So we've got -8 minus 2 squared plus -3 minus 5 squared. So we're going to get -10 squared plus -8 squared. So that's going to give us 100 plus 64. So that's going to give us 164. So again, we need to simplify this radical. So we're going to look at it and we're going to go, okay, it didn't have two exact numbers that allowed me to go, okay, well, they were both the same number, so I know I had two of them. But I can look at 164 and I can go, okay, well, 4 goes into it. And we look at our perfect little squares. So we go 4, 9, 16, 25, 36, 49, 64. 81. We look at our perfect squares and we see which one is the biggest one that can go into it. And the only one I see right at this moment is 4. So I'm going to look at 164 and I'm going to divide it by 4. And I know that if I do that, 4 is going to go into 16 4 times. And it's going to go into 4 1 time. And then that doesn't break down any further. So I know I can take the square root of 4 and the square root of 41. So the square root of 4 is 2, and the square root of 41 is the square root of 41. And that would be my answer. Remember, if you have any questions, you can email me, you can text me, and we can set up a meeting and I can help you through the work.